This is section 7.5, linear inequalities. It's been a while since we did any graphing, and this takes us back to when we were graphing number lines. Just a few reviews. When we're having an inequality, we want to have the variable on the left. Important idea. Second, we shade in the direction of the inequality. So if it's points left and it's less than, we shade to the left. So here we have an inequality shaded to the left with an open circle. The open circle is a reminder that we shade up to that circle, but we don't include that point. The only time we're going to include something is if it's in a situation like we have down here where it's equal to. If it's equal to, it's going to be a filled in circle, and then it's shaded to the right because it's an inequality going to the right. Now, we compare this with two variables, and in that case we're going to have equations of lines. Y equals mx plus b. Remember, m is rise over run, and that relates to the slope. B is the y-intercept. That is the starting point. So when we think of graphing our lines, we have to think about y equals mx plus b. Remembering with inequalities as well, when you divide by a negative, you change the sign. So we're going to talk about dotted versus solid now. A solid circle for a number line is like a solid line on a graph. An open circle on a number line is like a dotted line on a graph. It goes up to the line, but it doesn't include it. When we're shading our graphs, we no longer think left or right like we did before. Now we think shading above or below. Okay, so now all the times we think, we're shading above or below as we think and talk about our graphs. So let's take a look at our first examples down here at the bottom. Our first problem says y is greater than x minus 1. So before we start this, we're just going to do a little bit of a review. We're going to do a very quick sketch of what this graph is. As we examine our graph, we're going to start at the point negative 1. And I'm just going to make a little dot down here at negative 1. And as we think about our graph, we have to think, what is the slope? We look in front of the x for the number there. Well, there's no number there, and so it's an invisible 1. And so my slope is 1 over 1. So I'm going to go up 1 and over 1 from each of my points. Now, from up above, we talked about shaded in and dotted versus solid. This is not equal to, and so that means it's a dotted line as we go up. Since it's greater than, I'm going to shade above. Now above this, I'm going to put my two pens down. As I look at my two pens, the red pen is above the line and the blue pen is below the line. Since this is shaded greater than, we're going to shade everything above. Now is the time to answer the question. Does the point 3, 8 lie in the shaded section? Well, if I plot the point 3, 8, 1, 2, 3, and go up 8, that's way up here. Now, if I were to extend this line, as it properly would be extended, that red point up there would lie in the shaded section. What does that mean? It means that this point is a solution to this. How many solutions are out here? Well, it's an infinite number. We really can't write all of them down, which is why the shaded region is the only way we can show that. Now, I show all that to you just to help you understand what we're trying to achieve here. Does the point 3, 8 give an answer for this problem? Well, let's see what it does. Y is greater than x minus 1. We plug in the values. 8 is greater than 3 minus 1. 8 is greater than 2. Well, that's a true statement. And the reason it's a true statement is because the red point lies in the shaded blue section, everything above the graph. So you don't need to graph the problem. You can merely put the values into the equation to see if it's true. And then we can answer the question. The question says determine if it's a solution. Well, the answer is yes. It is a solution. Now let's look at the second problem, part B. Once again, while it's not required, we're going to do a review and do a quick sketch. I'm going to start at the point positive 3, put a dot, and I'm going to go up 2 and over 1 since my slope is 2 over 1. I'm just going to continue that pattern and go all the way up and down. Since it's less than and not equal to, once again it's a dotted line. Now less than, as I think of above versus below, I'm going to put my red pen on this side, I'm going to put my blue pen on this side. Which one's above, which one's below? Well, the red is below. And so that's the area I'm going to shade. I'm going to shade this red section of the graph. And everything over here is the shaded area. I now look at the point 1, negative 4. 1, negative 4. This is a black dot down here. Obviously it falls in the shaded section, so hopefully when we plug the values in, we should get a true statement. So here we go. Y is less than 2x plus 3. Negative 4 is less than 2 times 1 plus 3. Negative 4 is less than 2 plus 3. Negative 4 is less than 5. Well, sure enough, that's a true statement. So once again, we need to answer the question. Does this point give you a solution to this inequality? Well, since it's a true statement and it lied in the shaded region, the answer is yes.